Assalamualaikum and good morning. So next kita akan masuk subtopic 13.2 Kinetic Theory of Gases. So subtopic ni memang title dia adalah Kinetic Theory of Gases, di mana we are going to discuss about microscopic behavior. Okay, kalau kita cakap pasal microscopic behavior of an ideal gas, kita boleh describe dia menggunakan pressure, volume ataupun temperature. However, bila kita cakap pasal microscopic behavior, this microscopic behavior can only be described by kinetic theory of gases. Maksudnya we are talking about benda-benda yang micro dekat sini. Alright. However, there are few assumption of kinetic theory of gases yang kamu kena tahu. This assumption has been made to make things simpler lah kan. So the first assumption was all gases are made up of identical atoms and molecules. So the gases are all identical. Alright, next adalah all gas atoms or molecules move freely and randomly in all directions. So mereka akan sentiasa bergerak secara random and in all direction. All gas molecules makes a perfect elastic collision with each other and the wall of the container. So these molecules are going to be elastic. So bila dia tengah move in all direction freely and randomly, dia akan collide with each other. So when they collide, they will make elastic collision, di mana dia akan rebound balik. Begitu juga dia akan collide dengan wall dan dia akan rebound balik and continue its freely and randomly motion dekat sini. Next adalah the time of impact during collision is very short. So waktu dia collide, tak kisahlah dia collide dengan molekul lain ataupun wall itself, duration dia collide itu sekejap saja, macam pop terus rebound balik. And then the negligible forces between molecules except during the collision. So the forces between the molecule is negligible. So mereka takkan ada attractive ataupun repulsion force between each other. Cuma during the collision saja kita akan consider the forces dekat sini. How much force has been imparted on each other during that time of impact itu. And then lastly adalah volume of individual atom or molecule is negligible compared to the volume occupied by the gas. Alright, so the volume of the atom secara individual is negligible. Tapi bila kita combine semua atom ini jadikan dia satu gas, kita akan consider lah the. Okay, next kita nak tengok pada root mean square, RMS speed of gas molecule. Okay, what is a root mean square? It is basically a measure of speed of gas molecule. So kita nak ukur kelajuan molekul kita tengah bergerak tadi tu. So tadi kan kita cakap dekat atas ni, the molecules moves freely and randomly. So kita nak tahu with what speed dia tengah bergerak. It is defined as the square root of the average velocity squared of molecules of a gas. Okay, apa maksud? Ini adalah you have square root, ini square root of average velocity. Average velocity maksudnya kita ini average, tapi velocity dia bukan velocity saja, tapi velocity squared. So v squared, kamu squarekan velocity kamu averagekan dia dan kamu square rootkan dia. Itu maksud VRMS. Alright, this is actually an alternative method to calculate the magnitude of the average velocity of gas molecule. Okay, apa maksud dekat sini kita nak kira average apa maksud kita nak calculate the magnitude of the average velocity of gas molecule dekat sini adalah according to the kinetic theory of gases, the velocity of gas molecule is constantly changing in the direction. Okay, macam kita tengok dekat assumption yang dibuat, dia moves freely and randomly in all direction. So bila dia tengah move freely and randomly in all direction, contoh dia tengah gerak ke kiri, ke kanan, ke atas, ke bawah. So apa yang akan jadi dekat sini adalah net velocity dia akan jadi zero. Bila kita tambah dia, considering the direction atas, bawah, kiri, kanan, so plus atas, minus bawah, kita akan dapat zero dekat sini. However, dia tetap ada velocity, dia bukannya tidak bergerak. So oleh sebab itu kita menggunakan kaedah root mean square ini, di mana kita hanya nak calculate the magnitude of the average velocity of the gas molecule. So apa kita buat adalah, katakan dia tengah bergerak ke kiri, katakan dia tengah bergerak ke kiri, so kita akan ada velocity dia negatif, betul tak? So kita squarekan dia. So when you square, you're going to get the value saja, betul tak? So kita squarekan dia, and then kita averagekan dia, and then kita square rootkan dia. Itu maksud root mean square dekat sini. Alright, to deduce the equation for root mean square speed VRMS, kita start daripada equation of pressure of an ideal gas where the total force of all molecule is divided by the area. So when we're talking about total force dekat sini, the total force here becomes N multiply with the F average. Apa maksud N dekat sini adalah number of molecule. You have to consider all the molecules that is present in the gas. Lepas kita darab dengan F average because we are talking about the total force. Total force kan? So force dia ada direction juga. So kita akan ambil average force dekat sini. So F average in this particular kinetic theory of gases adalah M mean square speed divided by the 3D. Ini adalah mean square speed, iaitu average square of the speed. Alright, so kita substitute ini ke dalam sini, and then you will get an equation such as P is equals to N over D square. D ni adalah your area actually. M mean square speed divided by 3D. Okay, so D adalah distance travelled by the molecule. So the distance travelled by the molecule dia ke kiri ke kanan. So kita darabkan dia distance travel. N, capital N is the number of molecule. This symbol here is the mean square speed, and M kecil adalah mass of one molecule. So we simplify the equation. Kita simplify dia menjadi P is equals to 1 over 3 NmV, capital V, multiply with mean square speed. Apa capital V adalah volume, where volume adalah D cube. When you multiply your D square with D, you get a D cube dekat sini. So kita akan dapat NmV square 3D cube sebenarnya. So kita simplify dia menjadi 1 over 3 Nm over volume multiply with the mean square speed. Okay, this equation kita bawa V dia ke sini, kita akan simplify dia menjadi PV is equals to 1 over 3 Nm mean square speed, ataupun P is equals to 1 over 3 density mean square speed. Density dekat sini adalah number of molecule darab dengan mass divided by the volume, which is the basic mass over volume equation for density. Cuma kita ada number of molecule dekat sini because we are talking about the whole gas dekat sini. So PV is equals to 1 over 3 Nm mean square, ataupun P is equals to 1 over 3 density mean square speed. Okay, so bergantunglah kepada soalan. Kalau soalan minta suruh cari mean square speed, iaitu ini, dia suruh cari mean square speed, awak boleh guna either one of this equation, depends on the information given. Kalau dia dah bagi density, boleh terus guna equation ni lah. Kalau density, the bottom one, iaitu equation 2. Tapi kalau density tak diberi, kita gunalah equation ini, di mana volume is given, number of molecules dan juga mass is given. So kita boleh simply guna yang ini. Alright, however, we want to find the root mean square dekat sini, root mean square speed VRMS. So from the equation of state, PV is equals to NKT. This is the ideal gas equation. Kita dah tengok just in the previous video. Kita compare dengan equation yang kita dapat dekat atas. Equation pertama kita, iaitu PV is equals to 1 over 3 Nm mean square speed. So kita samakan this equation A dengan equation B. Alright, you equate these two, you will get NKT is equals to 1 over 3 Nm mean square speed. K dekat sini adalah Boltzmann constant, and we have discussed about this in our previous video. So you rearrange, you will get mean square speed is equals to 3 kT over mass. 3 kT over mass dekat sini. However, from the definition of root mean square speed, root mean square tadi kita cakap dekat atas ni adalah square root of average velocity square, iaitu square root of average velocity yang di square. So kalau kita tengok dekat sini, kita ada velocity squared average, betul tak? So root mean square adalah you're going to square root the average square velocity. Okay, since you have already got the average square velocity, ini kita dah ada, iaitu 3 kT over m. So kalau nak cari VRMS, kita hanya akan square rootkan dia sahaja. So VRMS is actually 3 kT over m, or menggunakan information such as K, Boltzmann constant is equals to molar constant over Avogadro number, kita akan come up with another equation for root mean square, iaitu Vrms is equals to 3RT over molar mass. So bergantunglah, kalau mass diberi, we use this first equation. Kalau molar mass yang diberi, we use this second equation, as K and R adalah constant, tak ada masalah dekat sini. So where Vrms here is the root mean square speed, which must be in the unit of ms negative 1 SI unit. Capital M here, this one is the molar mass of molecule, must be in the unit of kg per mole. Selalunya dalam soalan dia akan bagi gram per mole, awak kena convert pergi kg per mole. And then capital R here is the molar gas constant, 8.31 joule per Kelvin per mole, is a constant lah kan. And then small m here is the mass of gas molecule, must be in the unit of kg. K here is the Boltzmann constant, which has a value of 1.38 times 10 to the power negative 23 joule per Kelvin, and temperature must be in the unit of Kelvin. So awak tengoklah, kalau dia minta Vrms, apa informasi yang diberi, mass ataupun molar mass, and then you choose your equation. Alright, according to the Vrms equation yang kita deduce dekat atas tu, the lighter molecules moves faster than the heavier molecule at constant temperature. When the temperature is fixed, the mass of the molecule is going to indicate how fast an object is going to move. The lighter the mass ataupun the lighter the molecule, the faster it is going to move. And the next assumption adalah the speed of gas molecule is proportional to the temperature. So if you change the temperature, kalau temperature increase, the molecule is going to speed up, dia akan vibrate dengan lebih faster, and then dia akan gerak dengan lebih laju. Maka due to that motion sini, the Vrms here is going to increase as well. So Vrms is directly proportional to your temperature, which comes from the equation dekat atas inilah, dua-dua equation sini kita tengok dia directly proportional to the temperature.